Hey guys, so today we are learning about Gay-Lussac's law and the combined gas law. And so I wanted to give you guys some examples so you know how to do your assignment today. With Gay-Lussac's law, we're only working with pressure and temperature. So when you label these, you're going to have pressure 1, pressure 2, and temperature 2. Okay, and then as you're reading, you're going to fill in the information that you know and figure out which one you're solving for so you can choose the right equation. Okay, so the pressure in an automobile tire is 1.88 atm at 25 degrees Celsius. So we're going to fill those in. The first pressure is 1.88 atm and the first temperature is 25 degrees Celsius. Now you can't leave it in Celsius, so you have to add 273. Okay, so we're going to end up with 298 Kelvin. All right, and then what will be the pressure? So we are looking for pressure 2. If the temperature increases to 37, so that is your second temperature, 37.0 degrees Celsius. And again, you cannot leave it like that, so you need to add 273 to change it into Kelvin. Okay, so when we add these together, we end up with 310. Okay, so now what you're going to do is go ahead and make sure that your units are good. We change temperature to Kelvin and pressure is in atm, so that means when you solve, this pressure is also going to be in atm. Since we're solving for P2, we're going to use this equation. Okay, so P2 is equal to P1 times T2 divided by T1. Okay, so go ahead and plug that into the calculator and solve. Okay, so this one comes out to 1.96 atm. All right, on the next example, we are again working with Gay-Lussac's law, so it's pressure 1, temperature 1, pressure 2, temperature 2. Right here when you're reading, it says helium gas in a 2-liter cylinder. Well, liters is a volume, and with Gay-Lussac's law, we don't need volume, so that's just extra information. And it says that it's at 1.12 atm pressure. And then they changed the temperature to 36.5 degrees Celsius. So that's actually going to be your temperature 2, because it says that the same gas at that temperature has a different pressure of 2.56 atm. So when your pressure changed to 2.56 atm, your temperature also changed. And then it asks you, what is the initial temperature? That is T1. We're looking for what the original or the initial temperature is. And it also has another important piece of information. It wants your answer in Celsius, okay? Now, just because your answer needs to be in Celsius doesn't mean that you don't have to change that to Kelvin. You still have to change this to Kelvin first. So add the 273, and we end up with 309.5. Okay, so now that our pressure units match and our temperature is in Kelvin, we can go ahead and solve for temperature 1, which is going to be this equation right here. Okay, so temperature 1 is equal to pressure 1, 1.12, times temperature 2, 309.5, divided by pressure 2, 2.56. Okay, so go ahead and plug that into your calculator. Okay, and we get 135.41. And this is going to be in Kelvin because your other one is in Kelvin, so they have to match. Now, the thing is that they want your answer in degrees Celsius. Okay, so if you add 273 to Celsius to get to Kelvin, if you want to reverse that to go from Kelvin to Celsius, you have to subtract 273. Okay, so you're actually going to get a negative answer, negative 137.59 degrees Celsius. Now we're going to look at the combined gas law, okay? With the combined gas law, it's actually all three laws, Boyle's law, Charles' law, and GayLussacs law combined into one big equation. So you do see that the equations are a little bit more complicated because we are combining all three gas laws. So if you look right here, this is Boyle's law. P1 V1 equals P2 V2. If you look right here, V1 over T1 is equal to V2 over T2. That's Charles' law, okay? And then if you look on the other side, P1 over T1 is equal to P2 over T2. Okay, so that one is Gay-Lussac's law. So you have all three laws combined into one big equation, all right? So now as we're reading this, we're going to be looking for 6 things. P1, V1, T1, P2, V2, T2. Okay, so as you're reading, a sample of air in a syringe exerts a pressure of 1.02 atm and a temperature of 22 degrees Celsius. Again, add 273 to that. So that way it comes out to 295 Kelvin. They don't tell us the volume yet. The syringe is placed in a boiling water bath at 100 degrees Celsius. So that is your second temperature. You need to add 273, and we end up with 373 Kelvin. Okay. The pressure is increased to 1.23 atm. This is a good thing because both of our pressures are in atm, so they match. You don't have to convert them. And then it says the volume goes to 0.224 milliliters. So that is your second volume, okay? That goes with the other second pressure and second temperature. It asks you, what is the initial volume? So you are looking for V1. Okay, since we're looking for V1, we're going to be using this equation to solve. Now you notice here that there are parentheses. You have to use the parentheses in your equation. So when you're solving for V1, make sure to type in the parentheses in the calculator. Parentheses P2, which is 1.23, times V2, 0.224, times T1, 295. Close your parentheses, hit divide, open up a new parentheses, and then it's going to be P1, which is 1.02, times T2, which is 373, and then close the parentheses. Okay, so go ahead and solve. And this comes out to 0.21. Because we're solving for volume, our other volume is in milliliters, so this is also milliliters. Okay. And now our last example. A balloon contains 146 milliliters of a gas confined at a pressure of 1.30 atm and a temperature of 5. So those are all of our original conditions, okay? This is volume 1, this is pressure 1, and this is temperature 1. If the pressure doubles, okay, so it's saying the pressure is going to double. So we are going from 1.30 and we're doubling that. So that means that pressure 2 is going to be 2.60 atm. And then the temperature decreases to 2 degrees Celsius. So this is our second temperature. It wants to know what will be the volume. Okay, so we are looking for volume 2. Now we can't leave our temperatures as 5 and 2. Okay, so we need to add 273 to that, and that's going to make it 278 Kelvin. And if we add 273 to this temperature, it's going to be 275 Kelvin. Now that we have everything labeled, we are looking for volume 2. We're going to use this equation right here. Okay, so our volume 2 is going to be equal to parentheses P1, which is 1.30, times V1, which was 146, times T2, which was 275, close your parentheses, divided by, open parentheses, P2, which was doubled, right, of P1, so that's 2.60, times our T1, okay, and T1 was 278. Go ahead and plug all of that in and solve. Okay, so we're going to put parentheses 1.30 times 146 times 275, close your parentheses, divided by, open parentheses, 2.60 times 278, close your parentheses. And we end up with 72.21. Because we're solving for volume, you have to check your other volume. Those units are in milliliters, so this will also be milliliters. Okay, so these examples are posted on your module. So if you go to your Canvas and go under your modules, you're going to see the PowerPoint notes. So you can go look through the PowerPoint notes. There's more examples there. And then you can also see these examples that I just did. Okay, so here's the PowerPoint notes. Here are the examples that we went over. Then you have 2 assignments. So you have GayLussacs Law, which is 5 questions. You have 2 tries on that. It's due on Saturday at 5 p.m. Same with the Combined Gas Law. 5 questions, 2 tries, and due on Saturday at 5 p.m. Okay, so make sure that you work through both of these. I do need you to do at least one of these assignments. That way I can mark you present for today. So if you do not do any assignments, you're going to be marked absent. Okay, so make sure that you do at least one of them so I know that you were active during your class period. All right, everybody have a great day. Bye, guys.